Hello everyone. In this video, I'll be talking about the regular expressions in Python. Regular expressions are used for pattern matching, extraction, string manipulations, etc. So first of all, for using regular expressions in Python, we have to import the module for regular expressions. Import re. It provides many functions like compile, escape, find all, match, search, split, sub, etc. Now refer the documentation for regular expression. This module provides regular expression matching operations similar to those found in Perl. It supports both 8-bit and Unicode strings. Both the pattern and the strings being processed can contain null bytes and characters outside the US ASCII range. Regular expressions can contain both special and ordinary characters. Most ordinary characters like a, small a, or 0 are the simplest regular expressions. They simply match themselves. You can concatenate ordinary characters. So last matches the string last. There are some special characters which are used in regular expressions. This is what makes the regular expressions really powerful. In this case, the special character dot is used to match any character except a new line. Caret symbol is used to match the start of the string. Dollar sign matches the end of the string or just before the new line at the end of the string in the case of a multi-line. Then asterisk matches 0 or more repetitions of the preceding regular expression. Greedy means that it will match as many repetitions as possible. Then there is plus, which matches one or more repetitions of the preceding regular expression. Then question mark, which matches 0 or 1 of the preceding regular expression. Then there are combinations of asterisk and question mark, plus and question mark, and question mark and question mark. These are the non-greedy versions of the previous three special characters. Then for curly brackets m comma n is used to match from m to n repetitions of the preceding regular expression. This also has got a non-greedy version. That is, if this curly braces are followed by question mark, double backslash, either escape special characters or signals a special sequence. Then square brackets indicates a set of characters. A caret as the first character indicates a complementing set. That is, if the set is followed by a caret, then it means the matching characters should not include all the characters inside the set. Then OR operator, A or B, creates a regular expression that will match either A or B. Then brackets matches the regular expression inside the parenthesis. The contents can be retrieved or matched later in the string. In this RE, we can set some flags which can be supplied as additional parameters to the functions in RE. These are AILMSU or X flag. These are explained below. Then question mark colon, non-grouping version of regular parenthesis. Then we can name a group by using question mark P and giving the name. Else, these groups are indexed by using integers. Now, there are special sequences which consist of double backslash and a character from the list below. If the ordinary character is not on the list, then the resulting regular expression will match the second character. Since in this case, it uses a backslash, it is better to use row strings for writing regular expressions. Else it can cause confusion if we have to use the escape character, which is also a backslash in the case of Python. Slash number matches the contents of the group of the same number. Slash A matches only at the start of the string. Slash Z matches only at the end of the string. Slash small b matches the empty string but only at the start or end of a word. Slash capital B is the complement of slash small b. It matches the empty string but not at the start or end of a word. Similarly, we have got small letter d and capital D, which are also complements. While small d matches any decimal digit equivalent to set 0, 9 in byte patterns or string patterns with the ASCII flag. In string pattern without the ASCII flag, it will match the whole range of Unicode digits. As we have already said that capital D is a complement. That is, it will match any non-digit character. Then there is slash S, which matches any white space character, which is equivalent to slash T slash N slash R slash F slash V in byte patterns or string patterns with the ASCII flag. Capital S is the complement. That is, it will match any non-white space character. Slash W, it matches any alphanumeric character equivalent to a small letter A to Z, capital letter A to Z, 0 to 9 underscore in byte patterns or string patterns with ASCII flag. In string patterns without the ASCII flag, it will match the range of Unicode alphanumeric characters. With local, it will match the set 0 to 9 underscore plus characters defined as letters for the current local. Then capital W matches the complement, matches a literal backslash, double backslash. This module exports the following functions. That is match. Match a regular expression pattern to the beginning of a string. Full match. Match a regular expression pattern to all of a string. Search. Search a string for the presence of a pattern. Substitute occurrences of a pattern found in a string. Sub n does the same, but in addition to that, it also returns the number of substitutions made. Then there is split, which is used to split a string by occurrences of a pattern. Find all occurrences of a pattern in a string. Find iter returns an iterator yielding a match object for each match. Compile is used to compile a pattern into a regex object. Thus, the pattern can be reused. Purge, clear the regular expression cache. Escape backslash all non-alphanumerics in a string. So the flags are A, which is for ASCII. For string patterns, make backslash small letter w, small letter b, capital letter B, small letter d match the corresponding ASCII character categories rather than the whole Unicode categories, which is the default. For byte patterns, this flag is the only available behavior and needn't be specified. I is ignore case, that is, it is used to perform case insensitive matching. Then L, local, this is dependent on the current local. Then M is for multi-line, which matches the beginning of lines, that is caret, and dollar, which matches the end of the lines. Then there is S, which is dot all. This dot matches any character at all, that is, it will also include the new line. Then X, which is verbose. Ignore white spaces and comments for nicer looking regular expression. Unicode for compatibility only. Ignore for string patterns. It is the default and forbidden for byte patterns. This is an example to show the use of some of the functions in RE. In this case, this is a string to check the pattern, that is ABC, ABD, WE, FWER, ABC, CABS, ABC. And using the compile function, we have compiled a a regular expression pattern which can be reused. In this case, the regular expression pattern is written as a row string that we can see as from the R preceding the double quotation mark. Now we can see the output. Here the string is ABC, ABD, WE, SWER, ABC, CABS, ABC. Then this first is the output of the compile. Then second is using re.match. Returns a matched object with the position of the match ABC. Similarly, search also returns the match object with the position of ABC. Then find all finds all the occurrences of the pattern ABC in the string. Then using substitution, we have substituted the occurrence of ABC with the character sequence REP. Match and search are different. That we can see here. If we change the pattern to ABD, which has to be searched, then we can see that in the case of match, it returns none. This shows that match only is used to find the pattern at the beginning of the string, while search can find the pattern at any position in the string. Now we can see some examples of regular expression using special characters like caret, asterisk, plus, etc. For example, for a pattern for pin code, that is example of a pin code is given here 485901, can be as shown here. That is, it should start with a 0 to 9 set, that is any digit from 0 to 9 followed by 0 to 9 repeating any number of times. This regular expression can be further simplified using the plus operator as shown here, that is caret set 0 to 9 plus. This means there should be at least one digit. Now next we can see for writing regular expression for a pattern. Example is it contains at first there are 4 digits followed by a space, then by a capital letter, then a small letter, then any number of letters, and the regular expression can be written as shown here. Caret 0 to 9, 0 to 9, 0 to 9, 0 to 9 is repeated 4 times since the pattern contains 4 digits. Then A to Z, small letter A to Z plus, which means that a capital letter and a small letter should at least occur once. This pattern can be simplified to caret 0 to 9, curly braces 4. We don't have to write this square bracket 0 to 9 repeatedly. This can also be written as caret 0 to 9, curly braces 4, A to Z, small letter A to Z, curly braces 2, comma, which is equivalent to plus sign. That is, the length of the letter should be at least 2. Now we shall see about the match object. Match objects always have a boolean value of true, since match and search return none when there is no match. You can test whether there was a match with a simple if statement. Here it is shown that we match a pattern to a string and then use the if condition to check if there is a match. If there is a match, then a process is continued. Match objects support the following methods and attributes. First one is the match.expand template. This returns the string obtained by doing backslash substitutions on the template string as done by the submethod. Escapes such as backslash n are converted to the appropriate characters, and numeric back references as well as named back references are replaced by the contents of the corresponding group. In case of version 3.5, unmatched groups are replaced with an empty string. Then there is match.group, group 1, 2, etc. These returns one or more subgroups of the match. If there is a single argument, the result is a single string. If there are multiple arguments, the result is a tuple with one item per argument. Without arguments, group 1 defaults to 0. That is, the whole match is returned. If a group n argument is 0, the corresponding return value is the entire matching string. If it is in the inclusive range, that is 1:99, it is the string matching the corresponding parenthesized group. If a group number is negative or larger than the number of groups defined in the pattern, an index error exception is raised. If a group is contained in a part of the pattern that did not match, the corresponding result is none. If a group is contained in a part of the pattern that matched multiple times, then the last match is returned. Here, in this example, we have matched two groups of letters, that is R \w plus \w plus to the string Isaac Newton, physicist. M dot group 0 will return the entire match, and M dot group 1 will return the first parenthesized subgroup, and group of 2 will return the second parenthesized subgroup. And if we put M dot group 1, 2, it will return a tuple. If the regular expression uses the syntax, that is $P name, that is named group, the group and arguments may also be strings identifying groups by their group name. If a string argument is not used as a group name in the pattern, an index error exception is raised. A moderately complicated example. That is, in this case, the groups are named. That is, the first group as first name and second group as last underscore name. And these groups can be accessed using m dot group of first underscore name giving Malcolm and m dot group last underscore name giving Reynolds. Named groups can also be referred by their index. If a group matches multiple times, only the last match is accessible. That is, m is equal to re.match r dot dot, which matches A1, B2 and C3. But it only returns the last match. Match.get underscore get item underscore G. This is identical to m.group G. This allows easier access to an individual group from a match. There is m of 0, the entire match, m of 1. Now in version 3.6, match.groups default is equal to none. Return a tuple containing all the subgroups of the match from 1 up to however many groups are in the pattern. The default argument is used for groups that did not participate in the match. It defaults to none. For example, m is equal to re.match \d plus dot \d plus. For 24.1632 will give groups, that is in the tuple there will be two subgroups, that is 24 and 1632, that is to the right and left of the decimal point. If we make the decimal place and everything after it optional, not all groups might participate in the match. These groups will default to none unless the default argument is given. That is m is equal to re.match and question mark means it is optional. In this case, the second subgroup becomes none. Now m dot groups of 0, that is now the second group defaults to 0. Match dot group That is, it returns a dictionary containing all the named subgroups of the match, keyed by the subgroup name. The default argument is used for groups that did not participate in the match. It defaults to none. M is equal to re.match p first underscore name followed by \w plus. Then in this case m dot group d will give first name Malcolm, comma last name colon Reynolds. Then there is match.start group and match.end group. These return the indexes of the start and end of the substring matched by the group. Group defaults to 0, meaning the whole match substring. Return -1 if group exists but did not contribute to the match. For a match object M and a group G that did contribute to the match, the substring matched by the group G equivalent to M dot group G is M dot string M dot start G colon M dot ng. Note that M dot start group will equal M dot n group if group match is null string. For example, after M is equal to re dot search, B group is C question mark CBA, M dot start 0 is 1 and M dot n 0 is 2. M dot start 1 and M dot end 1 are both 2 and M dot start 2 raises an index error exception. An example that will remove underscore this from email addresses. That is, email is equal to Tony at the rate of tiremove underscore this dot net. M is equal to re dot search remove underscore this comma email. Then email m dot start plus email m dot end. Then it becomes Tony at the rate tiger.net. Now match.span. For a match M, return the two tuple m dot start group and m dot end group. If group did not contribute to the match, this is -1 group defaults to 0, the entire match. Then there is match.pos, the value of POS which was passed to the search and match method of a regex object. This is the index into the string at which the regular expression engine started looking for a match. Match.npos, the value of npos which was passed to the search or match method of a regex object. This is the index into the string beyond which the regular expression engine will not go. Then there is match.lastIndex, the integer index of the last matched capturing group or none if no group was mapped at all. Then there is match.lastGroup also. Then match.re, which will return the regular expression object, and match.string, which will return the string passed to the match or search. Now we can see an example of a Python program. In this case, there is a list in which first a phone number is written followed by the first name and the last name. This list has to be converted into the format as shown commented here. That is 5558396 new comma Allison has to be converted to Allison new 555-8396. This can be done easily using regular expressions. For this, we use grouping of regular expressions. That is, res is equal to re.search. Then the first group is r of parenthesis 0 to 9 hyphen asterisk slash s asterisk. Then the second group, capital A to Z followed by small a to Z plus comma slash s plus the third group, which is dot star. Then if there is a match, then we will print each group as shown. Now in this, indexes are used. We can use named groups as well, as shown in this case. So if we run this program, we can get the desired result. That is, this is the initial list. This is converted to the required format.